Okay, today lesson I want us to solve some questions on limits. We this one the limit has three different variables y, x, and z. Okay, so we have y, x, and z. So let's see how we can solve or how we can find whether the limit exists or not. So first thing that we need to know is that we can approach the 0, 0 or the point from both the x and y coordinates. Okay, so with the limit of x comma y comma z as it approaches 0, 0, 0, it means that when we have the point at the center here, let me go up. When we have the point at the center here, since we can approach that point from different perspective, so we can approach it by the y-axis and also by the x-axis and also by the z-axis. Okay, so let's see the condition for us to approach those points. Okay, so when we approach those points and the answer we get is the same, it means the limit exists. Okay, so let's move on. So we are starting with the x-axis. Okay, so on the line x-axis, I'm talking of this line x-axis. On this x-axis, you know that on the x-axis, both or all the other terms will tend to zero. So on the x-axis, my y will be zero, my z will be zero. Okay, so you just let the x represent, or you just make a variable for x, but we are making the x to be t. Okay, then you assign that t to approach zero. Okay, so you make x which is equal to t as t approaches zero. So the limit as x approaches t, it means wherever you see x, just substitute t there. That's why we said let s to be equal to t. So in our question, you just substitute t on where you see x. So that's the substitution I've done here. So on the numerator, you are going to get 0 over t square. Okay, but this place, mind you, don't further put t to be 0 here, because when you put t to be 0 there, you are going to get indeterminate. Okay, so wherever we have a 0 over a certain number, it means the result is 0. Okay, so 0 over any number is 0. Okay, so you are getting 0 from this part. And let's see for the y-axis. Okay, so for the y-axis too, the x and the y2 will tend to 0. So just make a substitution. That's what I did here. Then we are going to get t squared over 2t, because we said on the y-axis we define y to be equal to t. Okay, and we assign t to approach 0. So that's what I've done here. So as t approaches 0, just make the substitution. You are going to get t over 2. Okay, so the limit as t approaches 0, just make a substitution 0 there. So you are going to get 0 over 2, which is 0. Okay, so let's see for the next one. That's on the z-axis. So on the z-axis to y is equal to 0, x is equal to 0. So just make that substitution into our equation. Then we let z to be equal to t, and we assign t to approach 0. Okay, so just that's the substitution I've made here. So you are going to get 0 over t exponent 4, which is 0. Okay, but we can also try another form or another part, and the part that we are considering now is parametric equation. That's the parametric equation part. Okay, here we can't approach it by the line y is equal to x, or on the straight line we can't, because the function has two or more variables. That's x comma y and z. Okay, so we can use that part. This is what I'm talking about. We can use equation on y to be equal to x. We remember some of the questions we did this, but we can't use this because the function has both x, y, and z. This is what I'm talking about. This function. The function has y, x, and z. So we can't use that equation. Okay, so this equation is eliminated. Then we further on use the parametric. So here we can use the parametric but not this equation. Okay, so with the parametric, we make x to be t square and also make your y to be t square. You make your z exponent 4 to be t square. What all that I'm doing is that I want the exponent of both x, comma y, and z to be the same, okay, so that we can find the limit easily. So that's the rule for it. Just make sure that the numerator, the exponent of the numerator and the denominator for each of the variables x, y, z to be the same, okay. So when you assign x to be equal to t square, then it means that x should be equal to t. Sorry. So when we assign x squared to be equal to t squared, then our x should be equal to t. Also, when we assign y squared to be t squared, my y should be equal to t. Okay, mind you, I said we are doing in such a way that all the exponent of the x, y will be the same. Okay, so I want all of them to be in exponent 2. Okay, so that's what I'm doing. And this is the parametric form when we are finding a limit in x, comma y, comma z. So when we have equation that contain both x, y, and z, we normally use this form of parametric equations. Okay, so that's what I'm doing. Then you just plot in. So wherever you see my y is t squared. My y square is t square. Okay, so from the question, just substitute t square there. So I'm going to get t square plus 3 multiplying t, because my x is equal to t. And from the question to, so we are just substituting the values there into this original question. That's what I'm doing. So you are going to get t square plus 3 times t times t all over x square, but the x square is equal to t square. To just substitute all the values here by t exponent 2, and by doing that you make we will see that all the exponents are the same. Okay, so let's see. So that's what I'm doing here. So I'm just making a substitution. So we are going to get t square plus 3 multiplying t times t all over t square plus 2t square plus t square. Okay, so here you are going to get, when you add the numerator, you're going to get 4t square all over 4t square, which is 4 over 4, and you are going to get 1. So immediately you get 1, the 1 is not the same thing as 0, because when we did on the y-axis, we had 0, and when we did for the x-axis, we also had 0. When we did for the z-axis, we also had 0, but when we used the parametric equation form, we had 1. And because 1 is not equal to 0, then it means the limit does not exist. Okay, so thank you very much.